Thanks for joining us, mini mathematicians. Salutations. We're doing 2.1b lesson, rate of change together. Hopefully you have your printout. You'll also want to have some type of ruler or straight edge, and a few colors would be helpful as well. So let's take a look. Unit rate, and we've been talking about unit rate for a while, is a constant ratio that compares measures in which one of the terms has a value of 1. Remember, we defined unit rate as per 1. Well, rate of change is another constant ratio comparing change in y values, the dependent variable, with respect to change in x values, the independent variable. And we talked about that last class, how x is always the independent variable and y is the dependent variable. So because rate of change, and I want to write this down in our notes, rate of change is really important since it's the change in y values, change in y values over or divided by change in x values. We're going to be using this ratio a lot. And so to save time, instead of always writing change in, there's the symbol that's called delta. You see it a lot in science, and we're going to use delta y. It looks like a triangle over delta x. So when I say this means rate of change, and it's change in y over change in x. And this is the Greek letter delta, and it means change in. A lot of times we use it in science when we're talking about the change in temperatures, things like that. So delta y over delta x, or change in y over change in x, represents the rate of change. And all linear relationships show a constant rate of change. That's how the definition of a line is. We're going to have this come up throughout the entire module. All linear relationships have a constant rate of change. Pretty much the definition of a line, constant rate of change. Definition of a line, constant rate of change. Okay, so we're going to further explore the concept of rate of change by examining 3 different staircases. On properly built staircases, all the stairs have the same measurements. The important measures on a stair are what we call the rise, or the vertical measurement, and the run, or the horizontal measurement. When building a staircase, these measurements are chosen carefully to prevent the stairs from getting way too steep, and also you need to get where you need to go. So one step from 3 different staircases is given below. So we're going to have staircase 1 has a rise of 5 inches and a run of 5 inches. Staircase number 2, what's the run of this staircase? That's right, it's 3. Sorry, the rise is 3 and the run is 8. And our third staircase, staircase 3, what's the rise of staircase 3? Is 4, and the run is 6. Notice when we talk about the change in y values, if we look at a coordinate plane, x, y, the change in y values would represent the rise, and the change in x values would represent the run. So number 1, let's read the directions together. Using the rise and run for each step, graph the first 5 steps for each staircase. For each staircase, draw a connecting line from the origin 0, 0 to the point representing the final height after 5 steps. Okay, so I'm going to do staircase 2 with you, and you're going to do staircase 1 and 3. Okay, so staircase 2, we're going to start at the origin 0, 0. And notice staircase 2 has a rise of 3 inches and a run of 8 inches. So I'm going to go up 3, 1, 2, 3, and over 8. So 5, 6, 7, 8. And that's one step. So the second step, I'm going to go up 3, 1, 2, 3, and over 8. So that's 2. That's 5 plus 2, which is 7. So I'd have to go 1 more. And that's 2 steps. You do that again, up 3, 1, 2, 3, over 8. That's 4, so I'd have to go over another 4. That's 3 steps. I'm going to go up 3, 1, 2, 3, and over 8. That's 1. That's 5 to make 6. So I need 2 more to get 8. So that's 1, 2, 3, 4 steps. Just one more. Up 3, and that's 3. So I'd have to go over 5 more to get to 8. So that's 5 steps. I'm going to make sure I have the corners of my steps as points. Perfect. So pause the video and graph staircase 1 and 3. And remember, as you graph them, we're going to draw a line connecting the origin to the point representing the final height. So this last point that we graphed. And notice we're going to go through all of the points on our line, and it's going to make a line. So this was staircase number 2. Okay, so pause the video and graph staircase 1 and 3 and draw a line to connect them. Did you finish graphing yet? Did you pause the video? Okay, so this is what your graph should look like. Notice we have staircase 2, the least steepest, staircase 3, and then staircase 1. Staircase 1 was the steepest here. So those should be what your graphs look like. If you need to pause the video to fix any of them, you can do that now. So we're going to use these graphs to answer the following problems. So the next problem asks, state the rise and run for each staircase. State the final height for each staircase. Well, for staircase 1, remember the rise was 5. The run was also 5. And we went 5 stairs high. So if we have the height of 5 for 5 stairs, notice our final step ended up at 25 inches. So our final height was 25 inches because we had 5 steps going up 5 inches each time. Let's take a look at staircase 2. Taking a look at staircase 2, our rise here was 3 inches and our run was 8. So what was our final height? Remember, you had 5 steps, each step going up 3 inches. Well, if we look at our graph, our final height here was at 15 inches. And finally, staircase 3. Staircase 3 had a rise of 4 inches and a run of 6 inches. And if we rise 4 inches for every step and we had 5 steps, what was our final height? That's right. If we look at staircase 3, our final height was at 20 inches. So this next part is really important, so please follow along with me on your paper. All linear relationships have a constant rate of change. And remember, we called that constant rate of change the change in y over change in x. The constant rate of change is represented by the ratio rise over run, which is the slope of a line. So that's a really important word, is slope, this module and next module. And we use little m to represent slope because when mathematicians first talked about slope, we talked about mountains. Slope describes the steepness of a line. It represents the change in y values divided by the change in x values. So remember, if we drew a quick sketch of a coordinate plane, x and y, the rise would represent the change in y values, up and down, vertical. The run would represent the change in x values, horizontal, side to side. So let's find the slope of each line representing a staircase, and we're going to simplify. So remember, slope is rise over run. So we're going to write that a lot this lesson. Rise over run is equal to, for staircase 1, 5 over 5, which equals 1. Go ahead and find the slope for staircase 2 and 3. You can pause the video and find the slope for staircase 2 and 3. Good job. So staircase 2, if we look at the rise over run, we have 3 over 8. And we do not want to write these as decimals. We have to write them as ratios because we want to see the ratio of rise over run, which is really important. And staircase 3, if we look at rise over run, maybe you saw it was 4 over 6, but remember we have to simplify. It says to simplify up here. So my final answer for staircase 3, you got it, 2 over 3. If you didn't have the graph to look at, so before we could easily see that staircase 1 was the steepest and staircase 2 is the least steep. We don't say flattest because we talk about the opposite of steep, which is less steep. If you didn't have the graph to look at and could only look at these ratios calculated, how did you know which staircase was the steepest? Well, to find out which staircase is the steepest, you're going to look for the greatest ratio of rise over run. Staircase 1 is the steepest, has the greatest or biggest, you could say, ratio of rise over run. So we know that 1 is greater than 2/3, and 2/3 is greater than 3/8. So we have the steepest to the least steep here. Awesome, so let's keep going. We're going to calculate the slope for climbing 1 stair and 2 stairs and 3 stairs on each of the staircases. I guess we go up by steps, not stairs. That's a better word. So staircase 1. So let's take a look at staircase 1. Remember, staircase 1 has a rise of 5 and a run of 5. So when we went up 1 step on staircase 1, we went up 5 and right 5. So we had a total rise of 5 inches, a total run of 5 inches, and our slope, which is rise over run, is going to equal 1. Well, what if we went up 2 steps? When we went up 2 steps on this staircase, our final height was 10, or our rise was 10, and our run was also 10 after 2 steps. 10 and 10, which would be 10 over 10, which is 1. What happens after 3 steps? When we went up 3 steps, 1, 2, 3, at our 3rd step, we have a height of 15 or a rise of 15 and a run of 15 because we're going 5 up, 5 rise, and 5 over, 5 run. 15 over 15, which is also 1. Let's see if you can fill in staircase 2 and staircase 3. Go ahead and pause the video and fill in the staircases. Okay, let's see how we did. Staircase 2, for the first step, remember, we have a rise of 3 and a run of 8. So the ratio of rise over run is 3 over 8. And then after the second step, we double everything. So we have a rise of 6 and a run of 16. And if we look at rise over run, 6 over 16 is equal to 3 over 8. Oh, the same slope. And then if we triple, we go up 3 steps from our original. We have a rise of 9 and a run of 24. And rise over run, 9 over 24. If you scale down by 3, you get 3/8 again. When we looked at our staircase 3, again, our first step, we had a rise of 4 and a run of 6. If we doubled that, we had a rise of 8 and a run of 12. And if we tripled from the beginning, we had a rise of 12 and a run of 18. So if we look at those ratios, 4 over 6, rise over run, is equal to 2/3. Oh, the same slope we found for staircase 3. Let's see, rise over run, 8 over 12. Well, if we scale down by 4, we get 2/3 again. And if we have 12 over 18 and scale down by 3, we get 2/3 again. So what do you notice about the slope of the staircase as you climb up each step? As we climb up each step, does the staircase get steeper? Does it get less steep? The steepness stays the same. Does the slope change? No, steepness and slope are constant on a line. That means it does not change. Constant on a line. It's more efficient to communicate with positives than negatives. That's why we're going to say they are constant instead of they are not different. So taking a look. Suppose you want to make a skateboard ramp that is not as steep as the one shown. Write down 2 slopes you can use. Well, to talk about steepness, we can talk about slope. So remember, slope is little m because we talk about the mountains. And what's the ratio for slope? Do you remember? Oh yeah, rise over run. So if I take a look at this triangle, we have a rise and we have a run. So the steepness of this skateboard ramp is 3/5. But I want 2 different slopes that are not as steep. Maybe Mrs. Barr is going to try to go down or up this ramp and she's like, okay, I just need something a little less steep so I don't die. Okay. So let's think about ways we can make fractions that are less than 3/5. Do you have any ideas? Good idea. So if we want a number that's less than 3/5, we could increase the run. So we could have 3/6, which is 1/2. We could have 3/7 or 3/8 or 3/9, which is 1/3. So that's one way we can make the number smaller is by increasing the parts that make up the whole. Another thing we could do is we could decrease the rise here to make this less steep. We could make it decrease the rise here. So we could have 2/5 or 1/5. So I just want 2 different slopes that you could use, something that's going to be less steep. Good job. Okay, let's keep going. So number 8 says find the slope of the water slide. Calculate it in 2 different ways. So remember, if we're looking for the slope, we want the rise over the run. So there's something I need to tell you about. If we are going down, that's going to equal a negative rise. And if we're going up, that's right, that's a positive rise. Well, if we're going right, if we go direction right, that is going to be a positive run. And if we go left, that is a negative run. So it's important to have these directions because we might have an increasing or decreasing line. Notice this is a water slide that's going down from left to right. So I bet our slope's going to be negative. Okay, let's take a look at method 1. Method 1, I'm going to use the smaller triangle here. I'm going to use the smaller triangle here for method 1. So taking a look at method 1, remember our slope, or little m, is equal to rise over run. Well, if we look at the rise of this line, the rise of this line is going down. I go down 12.5, so I have a negative, and then I go right 50, so that's a positive run. If I wanted to write this in as a fraction, remember we need a simplified fraction, so I'm going to multiply by 10 to the numerator and denominator, and I get negative 125 over 500, which simplifies to be negative 1/4. Okay, can you think about a method 2 I could use to find the slope of this water slide? Can you think of a method 2 I could use? That's right, I could use the bigger triangle. So looking at this bigger triangle, and we know slope is rise over run. If I'm taking a look at this bigger triangle, the rise here, notice from the top I'm going down 25, so negative 25. I'm going right, so that's a positive 100. And 25 goes into both of these. So again, I get the same slope of negative 1/4. And that's because this is the same line. Its slope is constant on a line. Wonderful. Let's start number 9, and then you're going to finish 9 and 10 on your own and check with the video. So taking a look, it says use the diagram to complete the following. So looking at this diagram, notice I have a rise going up, so that's a positive, and I have a run of x. So it says the slope of the line is 3 over 2. So remember, that's little m. And we want to know what's the value of x. Well, we know that m is equal to rise over run. And yes, I do want you to write it again. So that means, well, our slope here is 3 over 2. And what's our rise here? Well, our rise is 6. And what's our run? Our run is x. Hey, we wrote a proportion. Do you remember how to solve proportions? That's right, cross products or cross multiply. So when we do this, we create a new equation, 3 times x, which is 3x, is equal to 6 times 2. So that's 3x is equal to 12. How do we get x by itself? Divide both sides by 3, and x is equal to 4. Cool. Let's start the next one. The next one says, if the slope of the line is 9 over 10, what's the value of x? Well, remember, slope, or little m, is equal to rise over run. Well, here the slope, m, is 9/10, and the rise is 6, and the run is x. Hey, we set up our proportion. How are you going to solve it? That's right, cross products or cross multiply. Go ahead and finish B and C, and then move on to 10 to use this diagram. Pause the video, and we'll go over the answers in a moment. Okay, how did you do? Let's take a look. 9B. After we set up our cross products, we had 9x is equal to 6 times 10. So 9x equals 60. Divide both sides by 9. You get x is 60 over 9. Scale down by 3, and x is 20 over 3. Great job. Let's take a look at C. So the thing that's a little tricky about C is that they say the slope of the line is 15, but all the other ones we had a ratio of rise over run. So what is the ratio of rise over run if our slope is 15? That's right, 15 over 1. So here, rise over run is slope. So our slope, 15 or 15 over 1, is equal to the rise 6 over the run x. How do you solve a proportion? Using cross products. So you have 15x equals 6 times 1. Divide both sides by 15 to undo multiplication, and then scale down by 3 to get x equals 2/5. Please remember to reduce your fraction. Number 10, we had a different diagram. So now we were given the run of 8 and a rise of y. We still know that slope is equal to rise over run. So here on 10a, our slope is 3/4, and it's equal to y over 8 because it's rise over run. We solve a proportion using cross products or cross multiply, and we have 4 times y is equal to 3 times 8. Notice I'm always multiplying my variable and the number first to have that on the left side to solve for y. Divide both sides by 4 to undo multiplication, and y is equal to 6. Taking a look at B, again, slope is equal to rise over run, and they tried to trick us by just giving us the slope of 5. Well, what is the ratio if the slope's 5? That's right, 5 over 1. So here, 5 over 1 is equal to y over 8, because that's rise over run. We use cross products to multiply and solve a proportion, and y is equal to 40. And our last problem, so they told us the slope of the line is -3. So slope is rise over run. So we have -3 over 1. Notice the negative only belongs to the 3. If that negative belonged to the 3 and the 1, that'd be -3 over -1, which is +3. So notice that negative only belongs to the 3. So we have -3 over +1 is equal to y over 8. Use cross products to solve, and you get y is equal to -24. Great job, mini mathematicians. Remember, you can use your notes on your exit ticket.